so we are now good to go. Confirm, you can see the slide. Okay. All right. Good. Okay. Yeah. So we can start now. Yeah. So I just want to take you through this first slide there. So we have about 14 slides to go, and this first slide is a little bit more in depth in terms of explaining what to expect in this data science journey. Yeah. So what we'll be doing is we'll be explaining through what each of these categories mean for the first of all from a business perspective, and then secondly from a tools perspective. So what tools you will need to learn as we scale this ladder. So the infograph that's in front of you represents two things. So first, in the x-axis is the level of maturity. Yeah. So you're able to see from the different skills that you're expected to have as a data scientist, the skills are varied. For example, at the first tier is a programmer, the second tier is business analyst. We have a statistician role, and then there's a business analyst role. On the extreme end is also a programmer role. Yeah. We also have a representation in terms of the analytics maturity. So this represents the level at which your organization is placed in terms of the maturity or adoption curve of the business. Yeah. So we have now, having said that, let me take you through the first part, which is the data quality. So for any business, and just to mention in line with what we talked about, digitalization aspect of business processes. So the first layer that you have in how your business interacts with your customers is the digitalization aspect. So for instance, in terms of payment, you may have digitalized how you collect payments from your customers. Or secondly, in terms of, for example, transactions. Yeah, so transaction could have shifted from the traditional to digital transaction. Just to give you an example of what's happening with the banking industry, for instance, where we are seeing the reliance on brick and mortar branches reducing, and most of the banks are now pushing digital banking. So at this level, the mobile phone is considered to be a virtual branch. Now you will need a programmer to create for you a mobile that can act as a mobile branch. Now what happens here is the parameters of the mobile app will have to be configured with a backend that can collect data. So the way the front end is structured, it should be able to collect the very right information that you will need for analysis. So that's what we call the transactional layer, which means whenever you're interacting with the customer, you have to collect the right information that will lead to the right analysis. Yeah, so after you've collected that data, now you see the need to do the descriptive analytics, which is always the very first thing that a business needs in terms of creating the KPIs and relating those KPIs to the business performance. At this stage is where you concern yourself with the various metrics. For example, periodical measurements. You can talk about movements of stocks. You can talk about attrition, turnover rate of customers, and then also internally you can look at employee churn, yeah, or you can look at recruitment rates. You can also look at the rate at which the sales or the cost on the production elements of our business. So we call it descriptive statistics because it does not do much in terms of analysis, but it just explains and describes. Yeah. The next part is diagnostics, and this concerns itself with identification of identifying factors and causes. We call it cause effect. And the diagnostics, now you start dealing with multivariate statistics. So you start creating things like mean, standard deviation, diversion of spread, just to see what is the pattern that the data is displaying. For instance, under descriptive, you might have just a chart that shows a trend, but that trend might not reveal much because a trend will just be linear trend. But then for the second level diagnostics, you deploy now some statistical models to start analyzing what and where uh, the story of the data means. So what is required at this stage? So first, from a skill perspective, yeah, you will need to, we'll expose you to some basic statistical models and the application of those models to solve specific business problems. Yeah. And for business, that will mean that whenever you're going to have a management meeting or whenever there's a business problem to be solved, you're able to answer and reveal hidden meaning behind performance. So it requires some special skills. And the reason why we are talking about data analytics is because now you will need special tools. For instance, we'll be able to use Python to create those patterns and being able to make coherent arguments at strategy meetings or uh, at a committee level. Maybe you're having a project you're doing in the business. Now, when you finish this level, now for the first level is where visualization comes. So we forgot to mention. So the skill you need at descriptive level is just visualization. So far, right now, I'm happy that you are using things like Excel. For the few of you that I've spoken to in terms of your users of analytics, you also are using PowerPoint. PowerPoint is also part of visualization. We have those ones who are using enterprise tools like Power BI, Tableau, Click. So it's good to have an interpretation of data using descriptive charts, but then it's also important to drill through that data, try to discover hidden meaning and patterns. So under diagnostics, also the other aspect is about correlations. Yeah. So the other thing that we will take you through is which data do you correlate with? So there are always two types of data in terms of origination. So there's data that you have internally as a business, yeah. And then there's data that you will get externally. You're able to create better diagnostics when you combine two types of data. Yeah. So we'll be taking you through a module called Outside Insights, which will particularly emphasize and shed light on which type of data you need to collect, especially when you're looking at the performance of different markets, when you're trying to predict and create models for demand supply, for instance, employee, labor, or commodity action, yeah, which actually operates on the principle that you do not have enough data internally, but you may need to acquire data from external sources. So this diagnostics is a critical component of data science because it helps you create an holistic view. Then predictive analytics, this is the part that has created so much attention. Yeah, most people are not just concerned about the what, yeah, and the why. Yeah, so descriptive is the what, diagnostics is the why, but predictive analytics is the when. Yeah, so you're looking into the future. Now, if this is the trend that we have now, this is what is going to happen in future. Now, we will start off by grounding you in one of the modules we call in decision science. And in that module, we actually prepare you for the various approaches in making decisions and doing forecasting. Yeah, so there are two philosophical approaches that we start introducing you to at that level. So the first one is how do you make decisions based on data? And also we make you appreciate that not all decisions are made using data. There are some instances where you may never have enough data or no data at all. Yeah? So we have special techniques we use for that. So let me explain the first one. When you have enough data, then it's easy for you to drill that historical data, and you can create things like time series analysis, linear regression, which can forecast into the future. But there are instances, so that nature of work is called epistemic, yeah, which comes from a Greek word called episteme, which is knowledge. Knowledge, basically meaning discovery. So you are doing historical analysis of data. And then the other side is when you don't have any data. Yeah. So we found, and if you remember the probabilities, I mean, for example, tossing a coin, the fact that you can toss a coin 100 times might not guarantee you that the pattern can be revealed by how many times you've tossed a coin. Those nature of problems actually allude to the fact that you cannot base decisions of the future based on historical data. So for that kind of problems, again, we have special algorithms that we use, and those problems are classified as aleatoric. Yeah, so aleatoric means based on lack of evidence. Yeah, so we have that problem. The other problem that falls in that category is like weather prediction patterns. It's very hard for you to predict when it's how it will. I mean, what how the weather will be tomorrow. Yeah, it's been sufficiently not been accurate to predict weather based on previous trends. So we ground you in those problems and be able to see which model do you use when you're predicting. So we don't just start saying predicting, not everything can be predicted using the same method. So we have various algorithms that we use and we'll be preparing you on the uses of each of those algorithms in the social context. So the tools that we'll use are similar tools. So still it will be Python when we're doing the descriptive. The libraries within Python that will be doing the descriptive. There'll be libraries within Python that we'll be using for diagnostics and then also for prediction models. So the most commonly one that you come across called machine learning will be at this stage of predictive analytics. Then the final layer is around a semantic. So semantic is understanding the social context and meaning. Actually, this is now the like the cap of everything. There's no need of you to predict something if you can't make a conclusion out of it. And Warren Buffett once said that the value of predicting a flood is building an ark. Yeah, so this is what it means. So basically, all the predictions that you have done have to find a meaning, have to find an avenue of application. So as a business, and when you focus your analysis to a business, this is what will be called the value of your work. So most data scientists focus more on doing the semantic value, where they provide the end product in the recommendation. So the most really common word is a recommendation engine. For instance, in the area of banking, when you want to predict the credit score algorithm, how do you rate the ability of someone to pay a loan? So the final product will be a score that's given as a decision tool to help the bank decide that this person will be able to pay the loan. Yeah. So there are various other applications in many industries, but these recommendation engines now serve as a purpose of making that clear distinction of yes or no. Yeah. Some examples of being able to understand the social context and meaning, we have things like text analytics. Yeah, so using special tools and algorithms. Yeah, and we'll be looking later into the diversity of data. We are saying that big data does not concern itself with only data that comes in zeros and ones, that's structured, but also unstructured data. Yeah, so you'll be able to see how you'll be able to analyze words and text and give meaning to the words and text in terms of sentiment, either positive or negative. That gives you a possibility of being able to analyze the sentiments around what people say on social media, what stories are being written in the newspapers, and correlate that with the things and experience the business is having. There's also network analytics, which gives you a view around what is the interaction between different networks. Yeah. So, for instance, there's what we call mobility sensors. So, how information moves from one place to another is determined by how mobile people are. So, disease patterns actually spread. There's a correlation between traffic movement and call network behavior and disease patterns. There's another part called the geospatial analytics, which is what we call location intelligence, and also based on the analysis of location in time and the, the way the location is, the way the location of time affects different things, like, for example, GDP, economic indicators of poverty index, security. Yeah. Then social media analytics, sentiment analytics, this go hand in hand because based on what comments your customers are making on social media, you can be able to profile whether they're happy or not. And the other part that's emerging is about image analytics, being able to do image classification, yeah, to solve business problems. For example, we can be able to analyze images a given scenario and match it to an existing database to be able to give a condition of proceed or not proceed. This is being used in agriculture to give loans. For example, farmers are uploading images of their cows, land, and the system is able to recognize the value of that image based on the parameters which have been defined by the system. Yeah, so this is just an overview, and depending on the maturity level of your organization, yeah, so you can see where to plug in. There are some skills which are easier to gain. There's some skills which require more learning and more reading. But in summary, a data scientist will be expected to have these roles. So one of the things we advocate is working in teams. So there's some skills which may be harder to acquire, like programming. They're not a default skill that are required at this stage, but whatever you can be able to learn based on the tools that will be able to give you, important that you start challenging yourself to learn a little bit more. Now, on this other side, how do you deploy these tools? For example, as a programmer, yeah, we'll be able to take you through the deployment options. Once you use Python to create a model, now we have other tools that we use to deploy them. For instance, the credit score will be deployed using an API. So there will be tools that you need to have, and those tools are constructed using programming skills. So just to be able to do a summary of this slide, yeah, remember that what you do at the beginning during the data quality defines what output you get at the predictive and the semantic stage. So it's basically garbage in, garbage out. So it's important to start learning yourself by asking the right question. Yeah, so we'll be splitting the course into 3 parts. So there's the part where we'll be explaining to you about the career, what opportunities are there. The second part will be about business modeling. So that business model will be helping you refine business problems and trying to understand what data science tools you can use to solve those problems, and which will lead you now to start talking about the tools. So the third part of this course is about the tools, and those tools are very pertinent so that you're able to ground yourself in the right avenue and learning path that can be specific to what solutions you're looking for. Yeah, so that's how you look at this slide. I would like to move to the next slide also, which is explaining, yeah, what you call the big data story map. Yeah, so these two first slides are very rich in terms of information. Yeah, so I'd like you to treat them as your reference point anytime you want to remember something that will help you in making a decision as we move on. Now, you've heard what we call a data lake. I'll just mention a data lake is a collection of various forms of data. So most organizations right now are driving what acquisition of data lakes, because we realized without data, then there's nothing much you can analyze. So data has to be stored in a right format. It has to be secured, ensuring the relevant data governance structures are there so that you can deploy the right algorithms. So I have kept emphasizing about the need to have two briefcases. So that you have a briefcase of data, then you have a briefcase of algorithm. So, but then at your level, you may need to understand that when you have the data that speaks the right language, then you're able to deploy the right algorithm to solve a problem that could otherwise not be solved. Yeah. So what do I mean by that? So traditional businesses have got various assets that they've been. Yeah, they have a framework for extraction, transaction, and loading, which is called the ETL for data. Now, what we're trying to do with this is trying to create the challenges of a traditional business, and we're trying to transition it into a modern landscape for big data. Business first is the way they process data. Yeah. So data warehouse challenges have been batch oriented processing. So for example, when you store data on SQL and you update it, yeah. There's someone asking a question here. By data, you customer info. Just you may need to ask that question a little bit clearer. Yeah, but one of the problems that we experience is how we process the data. Yeah, so for instance, I'd like to give a reference to one of the biggest problems that banks face. Yeah, so someone wants to take a loan, yeah, but the query has to be fed to the credit reference bureau, and that query is done it's done by batch processing. Yeah, so the database from the bank goes to the bureau twice every month, which means there's some low latency in access of the data. Yeah. So what will happen here is uh, when you transition now into a big data framework system, there's more high latency, which means speed of information flows a little bit faster. Yeah. So from SQL based to now what we call Hadoop based systems ensure there's more quick information processing, and which means decisions are able to be carried out in real time. There's also another aspect of brittleness and labor intensive. Yeah. So what is labor intensive? The skills required. Yeah, we need a lot of more people to work on them. Because of the lack of automation for some functions. Yeah. The other part is the performance and scalability challenges. So the accuracy of the data being stored becomes a little bit messy and dirty. Then it's aggregated and siloed. Yeah. So the siloed bit is a little bit big challenge for most uh, organizations because you find different databases for different business processes. So that brings in rigidness when you're trying to collect and aggregate the data that you're trying to aggregate the data that you're trying to compute. Now, what we are seeing is a transition, and when you look at the traditional town pouring data into what we call the data lake, so you're seeing these three V's here. Those three V's represent a part of a subset. We talk about 8 V's. Yeah, I'd share another document which talks about the 8 V's, but these 3 V's are what you call volume, variety, velocity. The volume representing the speed, the quantity with which then the data is coming in. Variety representing the diversity with which the data is coming in. So you can see it's both structured and unstructured. Yeah. So for unstructured, structured is what we are mostly deal with, but by unstructured, we are looking at HTML, websites, social media, images, videos. Then there's velocity. So velocity is the speed with which the data is flowing through. So this velocity becomes an aspect of latency. You need systems that can match the speed of data. That's why telcos and banks have a need to improve the speed with which information is accessed, so at least to enable decision making. Now, if you follow downstream that river, you'll see the types of data. So there's what you call deep data. This is data that's vertical but goes deeper. Then there's diverse data that's shallow but goes wide. So it looks at different aspects, for example, of a customer. When you go upstream, you start looking at the value journey. So what value addition do you need to add to this? Okay. So, for example, most organizations now are in the phase of retooling and reskilling their workforce. Yeah? So we may need to find a need to retrain the IT teams so that they can start appreciating the value of using big data storage platforms. Yeah, we may need to find a need to retool and reskill the executives and the board to appreciate and start creating data strategy. Yeah, so we always have a mission, vision, and statements for organization. but most of those have never been able to embrace the value of data. We've been talking about digital first, mobile first, but that's just been it. So we reach an area where those mobile first, digital first need to move a level higher and talk about data first. Then this value addition now ensures that there's entrenchment and the philosophies within the organization start shifting towards a data first approach. This brings in a level of operation where you're able to operationalize big data within the various departments. Yeah, so once the board has approved, the exco comes on board, then you're able to cascade down into operational levels. Now, I'll talk a little bit about the operational levels, so just to be able to see the different departments within the organization and how they can use data, so that at least you're able to ground yourself firmly. Yeah, but there's a specific module on each of these use cases for these departments. So finance is always the custodian of performance within an organization. So by performance, I mean return on investment, return on capital equity. So the various stakeholders expect some level of transparency in the performance of different business units. Now, the work we've done with finance in big data has always revolved around process automation, for instance, the volume of transaction and reconciliation. Yeah? So we are having systems which perhaps processing of payroll. So those systems have been developed by vendors like Oracle, SAP, Sage, but they still need to communicate with other systems. So when you're communicating with other systems, it means, for example, you would like to audit and see the variance in some set parameters. Yeah, so that actually process becomes manual. Yeah, so we've been able to work with the organizations that are in the space of investment financing, for instance, to be able to predict the right stock options where they can place their funds and with the more high return on the investment. Yeah, so it shows you the ability to use data science tools for creating predictions and have a value on the finance side. There's also the aspect of risk. Yeah, and risk is very broad. So one of the most repeated pain points in finance is fraud detection. Yeah, because of the systems that operate in finance are always fraud prone, especially on mobile. When we talk about the mobile ecosystem, not all customers have good intentions, so we find people always trying to access what's not there. So things like credit card fraud, mobile money fraud are becoming rampant day in, day out. So in finance, there's been a big use case of fraud analytic tools, which are driven by data science. Procurement, the need around procurement are just, it's very simple. How do you procure a big data system within an organization? So what we share with the procurement teams is the emergence of platforms that are open source. Yeah. We found one of our clients who was sold for an open source solution, and it was a little bit sad that they were not aware that that solution is open source, so it was free, but they ended up paying for it. So we consider that we need to raise awareness among the different organization departments, so at least to raise the profile. There's a business application use of procurement, which is a reputation and due diligence. Yeah. So, for example, some firms which involve themselves in corrupt deals, yeah, we can use big data to flush them out. Yeah, so information is posted online nowadays. Recommendation engine on Amazon or Google, Amazon or eventually Google, you need to analyze the data that's shared, yeah, and the recommendation that have been done by the different previous users. So that's the use of procurement. Product development, in charge of innovation. This is the where most companies put the data analytics team because it's still treated as an innovation. Yeah, so people, most organizations expect the data scientists to be able to analyze the data and create new value upstream. Yeah, but slowly this is a department that's coming into each and every department. So finance, we do product development, manufacturing and support product development, sales, and marketing and HR. So when we look at the use of data in product development, I think we are looking at how are you able to monetize data. We talked about data for dividends. Google itself is the best example on how they create new products using data. But the ability to create those products depends on a number of things. For example, market viability. How have you analyzed the various parameters of business and the consumer? Yeah. So a product development team, for instance, will not just have a data scientist who analyzes data, but it will have consumer psychologists, it will have anthropologists, yeah, it will have marketing teams which are able to analyze trends and do the prototyping. Then in manufacturing, the increasing use of automated tools are churning out a lot of data. Yeah, so IoT, Internet of Things, are bringing to the fore the use of analytics in manufacturing. No. Then sales and marketing, which is always tasked with ensuring that the top line grows. We are using data science to create lead generation mining, which again goes into distribution. There are things like location intelligence, being able to identify new pockets of new customers which we didn't have before. And secondly, reduction of costs of distribution. Customer experience, again, another bigger use of big data, the last mile value chain. So the customer is always the last mile. How you talk to the customer determines how the product is received. Now that's the best user for data because it requires a lot more collection of information. So for example, utility companies who have touch points of interaction with multitude of clients, telco companies have multitude of interactions with the millions of customers. Those customer accounts cannot be stored on traditional platforms for analysis. That's why you see telcos being early adopters of big data solutions. So what I think I need to prepare you for is look inward into your organization, isolate a department that has got the biggest need for analytics. If you already have a department, isolate an issue within your department that needs to be tackled, and then we can start working that journey together. And let me just give you, so the next slides will just show you tips on how you can use, they'll give you indicators on tips you can use to identify the areas of focus. Now, this is the way you can identify. Now, according to a survey which was done by the CIO, so I sit on the board of the CIO and they do surveys annually in terms of use of different technologies. So one of the survey which was done revealed that 49% are using data analytics for better decision making. So this could be a key yardstick for you if you want to place yourself in the minority. And that's why we have a module on decision science, and we'll be able to take you through how to make a decision, how to identify a decision that's valid for the business, so that you're not just making decisions based on trends that are not viable. The next category is 16%. These are better enablement of key strategic initiatives. So we're talking about strategy here. We're talking about next level of growth. So what we experience at this level is we're able to use data as a lever for strategic competitiveness. Yeah. So of course, what we do here is okay. So then I'll come back to the questions later. Yeah. So just keep posting the questions that you have there, and once we finish the slides, I'll go back and tackle them one by one. So better enablement of key strategic initiatives ensures that you're able to leverage data to give birth to new products. Then the 10% is about relationship with customers. The biggest pain point that most businesses have is customer attrition. So we have data about our customers, and then we need to leverage on that data to make the experience with customers more better. Then you have a better sense of risk. Yeah, so this is what now the audit departments come. If you're able to predict risk, then you're able to insulate yourself against the erosion of company assets or company profits. One of the products that comes out of this is credit score. Why do we give credit scores? We give credit score to prevent a loan defaults. Yeah. So when loan defaults are done, where when loan defaults happen, then the profitability of a bank reduces. Right now, we have those of you in the financial sector, you've heard about the IFRS. So the IFRS is a reporting standard that requires banks to declare upfront until they've collected a loan that has been given, not to declare it in their books. So that has created a need for better algorithms around knowing the customer and the sense of risk for customer. So customers are becoming an expense, yeah, until you're able to profile them accurately. Then the better financial performance. Number one, just to reduce operational costs. Number two, to enhance revenue on the top line. So this is where the data for dividends part. So this is another representation of this. So most of the organizations now are using some form of analytics that's helping the business. We are seeing another percentage, yeah, understanding customer trends and patterns. We have others using it for operation effectiveness, yeah, then for prediction. So you can place yourself in any of these four, yeah. So depending on where you are, yeah, trends and patterns, effectiveness, or prediction. And this is how the layer of prediction happens. So I've just unpacked the same pyramid. I mean, this pyramid represents now the steps that you will need to go through. And even in the tooling, we'll walk you through the tools from each. So we'll walk you through the tools of data collection and basic analysis. Yeah, so in Python, we have tools for doing basic analysis, data cleaning, which involves initial data recording and archiving. Yeah, then in data recording and very basic ad hoc analysis, which again will enable you have clear data that you can be able to project and act upon. There's also data integration and consolidation. Yeah, so this is the part of storing and modeling. So you'll be able to look at how do you store data efficiently, how do you integrate siloed data and apply data to quality measures. Yeah, also a critical part for making wise analytics. There's a part that some of you are already doing now, which is business reporting and analysis. So already business expects some reports generated maybe on a daily basis, weekly basis, monthly basis. How do you create a platform that can generate those tools, yeah, on automation basis? There's no need of you going to be doing manually to generate reports manually. Yeah, so this one of the things that data science does, automation. So we'll be able to learn how to automate and how we can use the basic Python skills to create reports that can be useful to the business. Now, after that, we move to the next layer, which is predictive analytics. Yeah, so of course, most people will be interested to know what's the trend, what is the performance next year, how do we come up with the systems that can address the issues that we have in 5 years' time. Now, the specific algorithm that will take you through that trends. Then the final layer, which is the cognitive analytics. So this cognitive analytics is the what we call understanding the context. Yeah, so it's the final layer where you're able to apply the prediction to the context of a customer. Yeah, so remember, customer is both internal and external. So whether you're looking at employees internally or whether you're looking at your customers who are external, the fact that you've been able to predict, how do you apply that to the behavior? And that's what we call the last mile. Yeah, it's always the hardest part. It involves a little bit more of collaboration with other team members, for example, the sales and marketing, customer service, but it's the sweet spot now of big data, because now that's where the rubber meets the road. Yeah, so next I want us to look at some of possible trends in data science, because in your career journey, you need to want to understand where you are. Are you in the right organization? What is the potential for you to grow within the organization that you're in? Or you need to start building your way out of the organization that you're in based on your interests in data. Of course, you realize that some organizations tend to have a bigger appetite for data scientists than others. Now, this a survey was done by an institution called Broadway Data Science Survey. Yeah, so it looked at over 1,000 data professions. Yeah, and then this is the spread of this, and the same reflects also in our context. So we are finding users, we are finding more usage of data science in information technology. So these are the Googles of these worlds, these are the Microsofts, Oracles. So they have the biggest appetite for data scientists. So you'll most likely find yourself uh, working there, yeah, if if you like to pursue those jobs being advertised in that sector never just end. There are jobs every week. There's also the part, the education and science, yeah, in academia. So the reason you're taking this course, as I've mentioned earlier, is we still are in the process of retooling and reskilling. We don't have, by the time we were studying, there were no colleges or the curriculum was not offering data science. So it's a new area which has come up. So the next big area is that education and science. Yeah. So it's intentional that you start building skills around training, because this could be an area where you can grow yourself, even within the organization, starting to train others, or even beyond the organization, the opportunities for growth, yeah, in terms of your passion. The other part is consulting. Yeah, of course, one of the things about that I've learned about data science is it's multidisciplinary. So you tend to work in different industries. Yeah, the same way you have a lawyer who can represent legal cases across, you have accountants who can work across different pillars of marketers. So is so is data science. The best way now to do it is through consulting. So we find that you're able to practice and set up a consulting firm to consult to meet the lack, the gap that's there in the market in this industry of data science. And you, yeah, think around those lines of consulting. It's an area that consists 13% of the job opportunities available out there in data science. We also have consulting firms like Deloitte, KPMG, McKinsey, PwC, who are mopping up quite a big chunk of data scientists on a part-time basis. Yeah, so it's good that you can keep an ear on the ground, see how those opportunities emerge. Then there's financial services. These are the banks. Yeah. Yeah. So of course, the need for risk modeling. Banks have been traditional users of data. So it's not by coincidence that they're here. They should actually be number one, but unfortunately, because of the regulatory nature of their industry, it's not easy for them to adapt to new technology. So they play laggards, but still have a high appetite for data scientists. We are seeing jobs being advertised like the latest I had was that Imperial Bank, we've had Barclays advertising for machine learning experts. Yeah, it's Cooperative Bank that's always hiring around that. So these jobs are going to be there, and the more and more solutions are being driven by data, the more these jobs will continue to emerge in the banking sector. Yeah. Then the rest that follow, not so mature industries in this country. For example, healthcare and medical. We 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 are not producers of pharmaceutical drugs, so we don't have a lot of companies here that you can say hiring data scientists from the medical front. Then media, yeah, media also. The share of media and the share that the media plays in the whole industry is a bit low also locally. But you might find in government, retail and consumer also, you'll have a lot of use for data. Yeah. So professional services also slightly, but not so much. But what I wanted to pick out here is engineering, oil and mining. So of course, much more will be needed at this level. And, we have sales and marketing. Yeah, all organizations have a sales and marketing function. We have big appetite. So as a country, I can say the most interest right now I'm getting uh, under this we have management and yeah. So management and HR have a better appreciation of data science. So most of the training requests come from them. So then after that, we have accounting. So accountants are also trying to embrace automation and how it's going to affect their career. There is also utility companies. Yeah, these are the Kenya Power. How do they grow revenue? Government is also concerned about increase in tax collection, so it's going to embrace data. Yeah, so just have keep an eye on the ground. These industries have specific uses. Yeah, specific uses of data in the different areas where uh, they influence. Now let me move to the next one. Different roles. So remember the first slide we were showing a statistician, a business analyst, a developer. As a data scientist, also you have 4 roles within you. First, you need to understand the business. Second, you need to have some level of programming. Thirdly, you need to be creative. Then 3, you need to be a researcher. Depending on which industry you are, yeah. So in information technology, you will need to be more of a developer. So if you're coming from an IT background, you have some programming skills, then this information technology is a natural home for you. Yeah. For those of you, yeah, who like to pursue academia, for instance, I'm in academia. Yeah. So that's to say that my interest is mostly on research, identifying new tools, new trends, and that's what we have been trying to push the envelope around adoption of new technologies in institutions. Yeah. So that's the space that you can consider. In consulting, again, it's also about research. So researching to see what tools organizations are not using and how do you fill that gap. Financial services also is about research and discovery. So you can see research cuts across in all industries. Retail and consumer, it's about business. So here is the business of turnover, churn, prediction. So you need to be very strong in marketing skills, understanding the concepts of churn, turnover, and how you create those solutions for the business. So retail companies, yeah, FMCGs, for instance, supermarkets, analysts and consumer products. These also are going to have a huge appetite for data scientists. Yeah, so I can move to the next slide. So at least to allow uh, some Q&A. Now, these are the skills that will be required of you. Yeah. Now, I just wanted to approach this cautiously because I'm not recommending that if you don't have math and statistics, that you go back to learn it in school. Yeah, what I mean is you may need to pay particular attention to the modules that will share with you around algorithms. Remember, I said that there are specific algorithms which have been created to perform specific functions. Yeah, of course, this is the basis data science. If you have a background in mathematics, then you have a longevity in the field of data science because you will not be looking at the entry level kind of opportunities, but you'll be going much deeper into doing things like machine learning, deep learning, and playing around with the modeling techniques. But this is also misleading when you say math and statistics because the best data scientists in the world now are coming from a physics background. Yeah, so globally, if you look at, if you check LinkedIn profiles and look at data scientists at Facebook, Google, you find the guys mostly have physics backgrounds. Yeah, so this shows an appreciation of math in the discipline, but does not necessarily limit you. Yeah, if you don't have those skills. Of course, we'll be going through the different analysis, and it might sound even a little bit unfair for guys who have done math to very deep levels because it only uses some section of the math knowledge, not all. Yeah. So you're more lucky to be in this field without studying math and statistics, in other words. Programming and database, yeah, of course, these are technology oriented. So this is the opposite. Math and statistics never change. Some algorithms which were created in the 1950s are being used now in Python. They never change. But on this side of programming and database is the part that evolves a lot. Yeah. So we have programming languages like Python, which never used to exist before, and now they're there. Yeah. So depending on what you want to ground yourself and what phase you are of your career life, you might need to consider where to spend more time. Yeah. So for example, what I'm saying about programming, what will we do? We have created the lab, yeah, which will constitute almost 70% of the learning, where we're able to impart the skills, tools, and library that you're able to use to solve specific problems for your business. Yeah, so you don't need to limit or worry about this. We'll not be doing this to convert it to be a developer, no. But we have a series that we run, we call Python for Business. So specifically going into Python, extracting the library that will help you solve business problems that exist. And of course, under different verticals, if you're in finance, there's a part for Python for finance. If you're in HR, there's Python for HR. If you're in marketing, there's Python for marketing. The foundations are the same, but the applications part much easier for to be able to talk a language that you understand. Then there are these lower parts here. Lower parts are always debatable, but this is now what draws the line. Yeah. So for instance, we are finding it hard to get placement options for a new graduated data scientist. So someone who just recently graduated from university, data science skills might find problem being placed because of domain knowledge and soft skills. The domain knowledge means you've grounded yourself as a specialist in one area. We also see diversity in this. You might provide a data scientist from a bank and take them to, for example, retail. Yeah, so they will struggle to settle down because the tools and the domain knowledge in banking is different from the tools that they use in retail. You can also find data scientists working for the same organization, sitting next to each other, but talking completely different languages based on their domain knowledge. Yeah. So, for example, someone working on the customer side might not have the same domain knowledge and same tools with someone working on the finance side. But what brings them together is the problem solving, hacker mindset, strategic, proactive, creative, innovative, and collaboration. Collaboration are very critical in data science. We always want to work and collaborate with other different departments, so at least to understand the problem better. And the next slide will be able to articulate that the survey which was done, and you can see the repercussions of not having collaborations or lack of understanding of a certain domain that acts as a barrier to the adoption of data science within different businesses. Yeah, so this other one, communication and visualization, and from the get-go, we are already building these skills within yourselves. So that's why we've been urging. So someone has already written an article on Medium, and they have actually invited me to read it. So yeah, so I'd like to encourage you to do the same if you haven't. Yeah, communication is also critical in terms of our presentations, arguing out concepts, using data to tell stories. So there's a particular series realization where we'll be teaching you tools and skills that can be used to tell data stories. Yes. So very creative ways of telling data stories, interactive ways. But then at the end of the day, what you communicate to your audience that makes them make a decision. Yeah, so this also goes beyond soft skills. So we are able to see art of writing. How do you write stories that people can align to? So remember, we told you are first a data scientist, then you're second a data evangelist. Telling stories about your capabilities and your brand will help unlock more opportunities for yourself. So these lower parts are more or less parts that you can start reading anywhere, but being aware of what value those skills have for you. But the upper parts, those are the parts that we'll be doing in the lab. Next slide. So this talks about the life of a data scientist. You can see, and as we move along, you'll be seeing the course that we are doing, also matching what is written here. For instance, the data science method that we use, 64% will be logistic regression, decision trees, random forest. So those are algorithms that will be taking you, and the application of them in business. So we'll be spending more time in the ratios given there. Neural networks is a new area, so it's more scientific, it requires more in-depth. But the maturity curve, if you challenge yourself at that level, then will be ready to work together at that side. So the average age, again, 30. This is relative. Why is it at 30? Because we are seeing that if you work for about 10 years in an industry, then you have a fair knowledge about that industry, then you become a good data scientist. Yeah. So we have, of course, you have junior level data scientists, yeah, who are learning at the same time as they work. But those ones who started in traditional departments, so when you enter, you don't go in as a data scientist, have a better chance of being data scientists because they understand the business a little better. Yeah, and they're able to do what we call reverse engineering when they're solving problems. Yeah, and the languages used, of course, we've told you we'll be using Python. So this is from a global perspective. 76% of the scientists are using Python. The biggest barriers to great work. Yeah, so we may need to express a lot of patience. You might want a promotion at work, but still the business does not understand the data science. Yeah, so you see there's also lack of data science talent. Yeah, so this means that if you're the only person in your organization, then you'll be overworked. Yeah, so you may need to see how to on that. Then lack of management financial support because they don't understand what it is. Yeah, they don't need the parts that we classify the differentiation between the other areas that are confused with data science. Yeah, so that's it. That's it from this section. Types of data used at work. Relational data, so that will still remain king. Text data, image data, these are growing. Yeah, but for now, we'll be focusing more on relational data. I think salary is debatable. Yeah, I know that part you want me to talk about it, but that's for you to decide for yourself if your value can meet those standards. By the way, the US is employing data scientists, so it depends. You don't push yourself, learn hard. Yeah, there are jobs, very many jobs. So there's a survey. I shared it on the group actually. Yeah, it was showing that a third of the data scientists in the US are not Americans. That number is continuing to grow. So feel encouraged in the right profession, though the numbers there. Yeah. So it's up to you to decide whether you want to uh, go for it. Yeah. So these are just an image that shows how you evolve. Yeah. So I want to believe that we are at this first stage here, this today, yeah, or we are at the data wrangling stage. But by the 3 months, 4 months, we should be at least working, yeah, with a small briefcase. The briefcase will not be having money, but I hope the tools that we'll have in that briefcase very soon we'll be having some in that briefcase. So this is just it's an evolution. You don't transform overnight. Yeah, it depends on the energy commitment you have to learn. So some little bit differentiation between this data architect, data scientist, data analyst. So data architect is concerned about representation. Yeah, data scientist, you can see the spectrum of data scientists from reporting, summarization, exploration, interpretation, and prescription. Whereas on a data analyst stage, they are concerned about reporting, summarization, and interpretation. So this scope is clear. Now, you might ask about movement and representation for data architect. So the version of this, if you're able to do this and this, you become a data engineer. Yeah, someone who does this entire thing is called a data engineer. Yeah, so there's a part of that also in this course. Yeah, but yeah, it's an area that has more demand than data science. But of course, you need to invest more time for learning. Now, these are the kind of differences in this. Some of the questions that a data analyst will ask vis-a-vis a data scientist. So, for instance, how do I solve reporting performance problems? But then a data scientist does not concern himself about solving and for report. He goes to ask, how do I balance model robust simplicity of the message? If you have a model, remember, it's something that is going to be automated. So you want to apply You're not doing spontaneous analysis. Yeah, you're going to analyze for posterity's sake. You build a model. Anyone who wants to use that model, you just plug in model. Analyze and move on. Data quality and sourcing problems. And here, how do I detect and quantify changing relationships? So this is aspect of dynamism. Yeah, so whereas a data analyst will be static, this other dynamic. What tools and reports are contextually appropriate? These are the side asking how can I correct for biased and incomplete data. Yeah, so the incompleteness of data, biasness of data becomes an issue. Another analyst will, but a data scientist will work to see that whatever issues that you have with the data can be corrected. Yeah, so this goes on. Yeah, you can see the differentiation in terms of branding. Yeah, so a data analyst will be a BI developer. Data scientist will be a data mining expert. Yeah, so SQL developers, statistics SMEs, visual analytic users, trusted advisors. So you can see the roles, how they differentiate between these two. Yeah, and these are the main users. Custom analytics. So as you model your problems, the biggest side of data science is on the business application side. So 48% on customer, 21 operations, 12 fraud and compliance, 10 new product and service, 10 enterprise, data warehouse optimization. So there's more demand for data scientists who are able to solve customer problems in short. Then followed by finance analytics, and then moving on. So lastly, these are the jobs which are out there. So you are seeing jobs changing, and you might, depending on the dimension or angle you're coming from, and I can use this to answer some of the questions. For example, Njoki was asking, kindly expand on data scientists in government. Yeah. So you appreciate the fact that government deals with records of data. Government deals with the regulatory frameworks and compliance. So we are seeing the role of a data scientist in government is to be able to institute measures that ensure that the government is able to invest in the right infrastructure to be able to understand the dynamics of its population. So, for example, the Kenya National Bureau of Statistics have got the annual census coming up this year. Yeah. So we have one of our faculty who's one of the advisors for that project, and they are looking for data scientists to help automate how the survey will be done. Yeah. So the government has an increasing need for data science. There's another project we are working with one of the government agencies called CalRO for agriculture. Yeah. So we have what they have is a funding from World Bank, and it's going to be a big data tool for collecting data information from farmers. So they want to train the government guys working on that project on big data. Yeah, so we are seeing now government starting to embrace that. We have data-driven and advertising. Yeah. So I know Sylvia is there. So you are working in the national media, and then how are you able to start creating products which are driven by data to be able to understand your customers well? There's a part we call customer ethnography. Yeah. So we have Ken, we have Dennis, who works in BAT. So how are you able to use this to understand your customers better so that you can provide insights for the business? So people data scientists, this is for Judy and Dennis. So this is on the people analytics side of the business. So how well are you able to anchor the business decisions for the company employees based on analytics? So it's an area that's growing, and your role now will start shifting to this. We have behavioral economists. Also, these are people who work in government, trying to create policies, economic policies to be able to answer. And there's something that Lynette was asking about. Where do we place public policy in? Like, how can one review a critical policy using its descriptive So this is where it is behavioral. Yeah. So you, depending on what policy it's addressing, you trying to analyze on how that can impact the behavior of the given population. So there's a guy who won a Nobel, yeah. So he's written a book called Misbehaving. It's called Richard Thaler. He's a behavioral economist. I would like you to, I'd recommend that book. I'll share the book as well. I think I've got a copy somewhere. You can be able to see how you use data for economic policy planning, because policies are shaped by behavior. We have social physicists, data journalism, being written, I mean, using data to write data stories. So Nation Media has got a platform called Newsplex, which again is a product of data journalism. Yeah, so I think I've been able to answer a few questions based on that. There's Kennedy who's asking a question here: how can Python help data completeness for gaps brought by human factors? Yeah, yeah. So using the Python library of pandas and NumPy, you're able to create that cleaning. Yeah. So you can automate the cleaning by feeding in commands. Yeah. Then you're asking an easy Python book for starting users. Yeah, so yes, we have a couple of books. So we'll be sharing with you those books granularly so that as we share the knowledge and the tools, we point you to the areas that you can read. But if you'd like me to drop a library, there's a big library with many books which you can choose for yourself. Yeah. Yeah. So any other questions? So I think we can be summing up in about 5 minutes. I have a few minutes for take up your questions. Yeah. So Joseph is asking if data science and cybersecurity is connected. Yeah, of course, they're connected in the area of data governance. The best example I'd like to give is a company with a lot of data and store that data. So around the elections, there are people who steal data. For example, records, voting pattern records, they steal credit card details, they steal contacts. So issues cybersecurity are very much entrenched in data science, but I would like to put it more on the data engineering side, not the science side. Yeah, so it's more on the infrastructure. Any other question? Yes, yes, Catherine. Yeah, so yeah, we should be able to get the recorded version of this. Yeah, so we'll work on that. Dennis, clarify on. Okay, yeah, the velocity, is it system speed or data uptake? Yes, so it's on data uptake. Yeah, thanks for asking. So it's on the data side. Yeah. Okay, cool. So I know it's late into the night. My apologies for starting late for the technical hiccup we had. But we'll always be we'll always focus on preparing ourselves early for you. We had a guest today. I think I don't know whether he's still on. Okay, but he left there. But I'm happy to, yeah, I'm happy to have taken you through this. So let's keep the conversation going. I'm still expecting you to send through your profiles, and yeah, we'll be communicating on the expectations on assignments. There's a book which has been posted on Slack for you to review. So I'm also hoping you find time to read 1 or 2 chapters there. Then you can review. Yeah, yeah. But keep learning. I'll be sharing a file on Slack for your weekend reading on Python. Yeah, just I'll give the instructions on as we prepare to move towards the technical side of this course. Yeah, there's all the best. Enjoy the rest of your week. I'll be traveling back to Nairobi tomorrow. So yeah, best regards from Kampala.